Okay, good evening to all. I will start the session. Okay, in this session, we are going to discuss this problem. What is this one? Merge sorted array. The name specifies we have given two arrays. By seeing the name only, you can understand. We have two arrays. Each array is already in sorted order. Your aim is you need to merge. Sorry, see this one. You are given two integer arrays nums1 and nums2 sorted in non-decreasing order. That is, the two arrays are sorted in ascending order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. Till now, what they are given? They are given two arrays in the form of list only. They given two arrays. Array 1, that is list 1 nums1, which consists of m number of elements, nums2, which consists of n number of elements. Now merge nums1 and nums2 into a single array, into a single array sorted in increasing order. You got the point? Now the final sorted array, the final sorted array should not be returned by the function. The meaning is, till now, while completing the program, we are returning the answer, return something. But in this question, what they said, should not returned by the function, but instead be stored inside the array nums1. That means the result is stored in nums1. To accommodate this, nums1 has a length of m plus n. Yes, I think you got it. Why? Nums1 length is m, nums2 length is n. M is incremented to m plus 1. In that, the first two m elements denote the nums2 has a length of 4. Now consider this example. Observe nums1 1 2 3 0 0, m is equal to 3. Sorry, here 6 elements, m is equal to 3. In the question only they given like this. So m is equal to 3 means the first three elements of nums1, remaining these three side of n. So here 1 2 3 is in sorted order, 2 5 6 is in sorted order. Now combine these two, merge into a single one. Merge into a single one. Suppose see this one 0, m value 0, nums to 1. So 1. Now I will explain with one example. Understand carefully. I have an array nums1. So consider the elements, suppose 4, 7, 9, some 0, 0, 0. Here, what is m value? M value is equal to 3. Now, nums2 is equal to, for example, 5, 8, 11. What is n value? N value is equal to 3. Now, in the question, how they given in the last two paragraph, they mention like this. In my program, I given size of num elements of the y after adding to avoid any problems. Why? In the program, it does not return any value. What is the procedure? We can do in these two ways. We can do the program in these ways. What is your final answer? I think you understand the question. The final answer is 4, 5, 7, 8, 9, 11. This is available in nums1. This is my final answer. Merge the two arrays such that merge two arrays, that is two lists, such that The elements are in sorted order. The elements are in sorted order. Right now I will explain two ways, but the two ways are very very important. Two ways are very very important. Okay, what is the first way? Very basic approach, very very basic simple approach. Now take only these elements, take only these elements, or these elements, these elements are placed here. The 0 is replaced with 5, the 0 is replaced with 8, 0 is replaced with 11. How? Single element means by using single index. Multiple element copy means slice operation. Now observe nums1 of m colon. What is the meaning? Already they given m is equal to 3 for this purpose. Nums of 3 colon. This is 0, 1, 2, 3. 3 colon. Here I am not given any ending point. That means until end of the list is equal to nums 2. For example, again I will repeat, you have a single element. Suppose nums of some index 4 is equal to 20. At index 4, I am placing the element 20. But here my aim is not to copy a single element. I want to copy n number of elements. Already they given some space to you. For storing n elements, they given n zeros. But where it starts, already first 0 to m minus 1 elements are fixed. That is the reason I written this statement. What happened? Once you written this statement, nums1 is equal to 4, 7, 9. Those are not updated. From position 3, nums2 elements are copied 5, 8, 11. 5, 8 to 11. You got it? Now I think you know that logic. So you need to arrange these elements in sorted order. Nums1 dot, use the method sort. Here, right here, nums1 dot sort. By writing these two steps, the program is completed. The program is completed. What I am doing? Simply the second list is placed at the end of the first list. The second list is placed at the end of the first list. Now all the elements under list nums1. Simply I am calling sort operation. Simply I am calling sort operation. Once you are calling sort operation, what happened? The elements are arranged in ascending order. The elements are arranged in ascending order. Here in the question, they are not mentioned the word predefined methods are not allowed. Predefined methods are not allowed. Then you are moving to another procedure. You got the point? Anyway, I will explain that in some situation don't use sort method. Then what you are doing? For that, I will explain nums1 is equal to, for example, we are taking this numbers only 4, 7, 9. 4, 7, 9, 0, 0, 0. M is equal to 3. Nums2 is equal to, nums2 is equal to, I taken 5, 8, 11. Whatever the numbers, that is not a problem. 5, 8, 11. N is equal to 3. This is the input to the program. This is input to the program. Now, first to understand what I am doing here, I am using this ignore. I am using two indexes. One is I, another one is J. One is I, another one is J. What I points? Actually, I need to place nums2 in nums1. So this is 0, 1, 2. I want up to this position. So I is equal to m minus 1. M value is equal to 3. 3 minus 1, 2. So that means from 0 to 2, my nums1 elements are stored. You got the point? So 0 to 2, nums1's elements are stored. I refers to this position. I refers to this position. So now I points to index in nums1. Similarly, for nums2, I am using j value. J is equal to n minus 1. Now j points to index of nums2. Okay. So two variables I and j. First list is pointed by I. Second list is pointed by j. Now, what is the important thing? What is the main important thing? You need to place this value. For that, assume one variable k. Anyway, names are anyways. So, initialize a variable k which is used to store the index, which is this the last index of the first array. For example, I am using some variable k. K refers to this position. You got it? Why k only? That why array 1 only? Array we need to store the result in array 1, that is list 1. Again I will repeat. I points to this position, that is these are the original elements existed. Originally these elements are existed, that is the reason last position is I, that is m minus 1. Here originally these elements are available. Now j points to this position. Now to store the value I need to remember the last two position k. Now, what is the value of k? You know that one. Sage is m plus n, 3 plus 3, 6. 6 minus 1. Why? Starting from 0. 0, 1, 2, 3, 4, 5. So, k is equal to 5. 5, how we are getting 5? M plus n minus 1. M plus n minus 1. Now, I think this is clear. Here, right now, I am not doing any logic. Just I am storing the indexes. Sorry, again the question. Why the indexes are required? Why? To copy, to perform sorting. Where we are copying, where we are doing sorting operation. For all that purposes, we need the indexes. We need the indexes. Now, now first I am doing, repeatedly you are copying the operation, yes or no? Repeatedly you are doing copy operation, while uh, here we are copying which elements? Array 2, list 2 elements, list 2 elements. First j points to last position, that is 11, 8, 5. So j is greater than or equal to 0. Initially I is equal to 2, k is equal to 2, k is equal to 5. Yes or no? According to this example, this, while j greater than or equal to 2, that means 2 is greater than or equal to 2. 2 is greater than or equal to 2. Now what you are checking? The first array, this 9 is compared with 11. Sir, why 9 and 11? That is the very, very important. Already, these elements are in sorted order. These elements are in sorted order. For example, nums1 of I. What is nums1 of I? I value is equal to 2. Nums1 of 2, that is 9, is greater than nums2 of j. Nums2 of j. For that comparison purpose I used ing. I think you got it. So I points to the first list, j points to the second list. First what I am doing, 9 is compared with 11, yes or no? Condition false. If the condition is true, we are doing some operation. Yes, condition is false. Now understand carefully. This is the highest element in the nums1. This is the highest element in nums2. So 9 greater than 11, condition fall. Where 11 is placed? Where 11 is placed? The possible position for 11 is this one. Yes or no? Why? Among these three, 11 is the highest. Among these three, 9 is the highest. Compared to 9, 11 is the largest one. So, the possible position for 11 is this one. What is this? K. So, what you are writing? Yes, nums1 of k. At kth position, you are placing nums2 of j. Yes or no? That is, at kth position, the value nums1 of k value 5. Nums1 of 5 is equal to nums2 of 2. So that means at this position, 11 is stored. Now, k is filled. In the next iteration, you need to place element at this position and you need to compare this element. Yes or no? For that, what you are doing, k is equal to k minus 1, j is equal to j minus 1. That means what is j value? J value updated to 1, k value is equal to 4. K value is equal to 4. Again, check 1 greater than or equal to 0. Nums1 of I. I value 9. I am not updated till now. 9 is greater than nums2 of 1. J value 1, nums2 of 1. That is 8. 9 greater than 8. 9 greater than 8. Then what you are doing? 9 greater than 8. That means this 9 is copied here. Yes or no? Why? Because if you are placing 8 here means the sorted order is failed. Compared to 9 and 8, 9 is the largest element. If 9 is the largest element, inside the if what I am doing, nums1 of k at kth position, you are writing num1 of I. And then that is 9 is copied here. 9 is copied here. Now I value is decremented by 1. Why I is decremented? We are copy the element from nums1. If you are copy the element from nums2, j is decremented. Anyway, k is equal to k minus 1. So in the next iteration, I is equal to 1, j is not updated, k is equal to 3. Anyway, k is updated. Now, nums1 of 1. Nums1 of 1 is equal to 7. Nums1 of 1 is equal to 7. 7 is greater than nums2 of j. J value updated, j is equal to 1, 8. 7 greater than 8. The condition false. Whenever the condition is false, we are moving to else. See this one. Nums1 of 3 is equal to nums2 of 1. That is, what is this nums2 of j? 8. 8 is copied into this position. 8 is copied into this position. Value is also decremented. J is initially 1. Now 1 minus 1, 0. 0 greater than or equal to 0. Nums1 of I. What is I value? 1. that is 7 greater than 5. The condition is true. If the condition is true, nums1 of k value 2, at second position we are copy 7. At second position we are copy 7. Now I is equal to 0, k is equal to 2. I is equal to 0, k is equal to 2. Yes or no? Now, nums1 of I is equal to 0. That is 4. 4 greater than nums2 of j5. This condition false. Coming to yes. At second position, we are placing 5. At second position, that is k is equal to nums2 of this one, we are placing 5. Already k is decremented, k is 3, k is 2, here k is equal to 1. Here k is equal to 2, k is equal to 1. At the first position, we are placing 5 and j value is equal to minus 1. K value 0, j value minus 1, minus 1 greater than 0, the condition fail. We are coming out of the loop. We are coming out of the loop. The elements are in sorted order. And at last, for example, here 3 only. Here 3 only. Nums1 of I, that is 4 greater than 3. The condition is true. What is I value 1? I is equal to, that is nums1 of k is equal to nums1 of I. 4 is copied here only. I value is 0. K value is equal to 0. Whenever I value is equal to 0. Okay. In the next iteration, simply there is no element. We are placing 3. That is, we are repeating the loop I greater than or equal to 0. Once I value is negative or j value is negative, no need to repeat the loop. Think you got it? Anyway, it is complicated, but understand the most important. So I think in most of the members it seems complicated. Sir, it is a very simple by using single statements. Yes, that is fine. But that is not at all important. Everything you are using predefined, then what is the use of right learning the logic? This is my logic. Again, repeat, what is the logic? Comparing element by element. So, last two elements are compared. Whatever the largest, that is placed at the last position. Next to element, largest is placed. In each and every iteration, two elements are compared. Whatever the largest is placed. If you are copying from nums1, I is decremented. If you are copying from nums2, j is decremented. For that reason only, I am using these variables. K is used for placing the elements from the last two position onwards. I think you got it. Now, colon is equal to nums2. So the first approach, I am doing the first approach, nums1 dot sort. Done. See this one, it is accepted. See, it is accepted. So anyway, that is fine. But not only one logic, you need to learn two things step by step. Again, remember, I will explain again one by one. Here, first I am using one variable I, which is used the last element in the list one. Last element in the sense original elements, not zeros. M is the last element, which I is used to point to the last element. J. J is used to point to the last element in list 2. I am using one more variable. K is used the last two element from nums1, that is including zeros. How we are getting m plus n minus 1. Now three variables. We are repeating a loop until how many number of times? Very simple. Until n list 2. List 2 contains of three elements. The loop is repeated three times. That is, you need to place all the three elements. Yes or no? That is the reason while j greater than or equal to 0, then only I am repeating the loop. And at the same time, I greater than or equal to 0, end. I value greater than or equal to 0, end. Observe my logic. List 1, first last element. Already list 1 is in sorted order. List 2 is in sorted order. List 1, last element is compared to list 2, last element. If the condition is true, means list 1 last element is greater. List 1, the last element is greater, then that element is moved to the last position. What is the last position? Index k. So that is I am doing. Nums1 of k is equal to nums1 of I. So which list has the largest value, that is placed. Once that is placed, k is decremented. Why? One element is already placed fifth position. Now you need to place at fourth position. We are copy the element from I or j. If this condition is true, means you are copy the element from I, that is from list 1. So decrement I index. Now, exactly else, once you are coming into the else means the condition fail. The condition fail in the sense list 2 has the largest element. Now, nums1 of k, that is under the last position, under the k position, you are writing nums2 of j. So nums2 of j means second list has the largest element. Now k is equal to k minus 1, L, j is equal to j minus 1. What is the meaning? Whether you copied from list 1 or list 2, k value, one element is placed, k is decremented. If you copied from list 1, I is decremented. Copied from list 2, j is decremented. J is decremented. Once this loop is repeated. Submit. Okay, executed or not? So you can do any approach. That is not a problem. In the question only, they are not given. Don't use sort method. No, I think clear. Moving to the next problem. Gray code, subset, decode, reverse, easy, binary tree in order. So again, so in the previous session, we got one example related to linked list. For that, I explained linked list. Now, in the last session only. Now here we have the concept of tree and traversal. I will explain that one. So tree, what is a tree? Some set of elements are arranged in hierarchical fashion. So root node, left child, right child, like this. Here especially binary tree. Binary tree. Binary tree means consists a node or a vertex, called anything, a node or a vertex, consists of at most two children. A node can have maximum of two children only. Such trees are called binary trees. So Traversal. What is the meaning? Traversal means visiting all the nodes in the tree. Visiting all the nodes or all the vertices in the tree is called traversal. Here we can do the traversal in three ways: in order traversal, pre-order traversal, post-order traversal. In order, pre-order, post-order. We can do anything. Now, what is in order, pre-order, post-order? We'll explain step by step. Consider one example: 10, suppose 9, 15, for example 8, 11, 13, 14. Here there is no condition: left side elements less than, right side element greater than. That is a binary search tree. Here the binary tree means a node can have maximum two, not compulsory. 1 is also sufficient, 0 is also sufficient. For example 15, 16, 19, 20. This is a binary tree. This is a binary tree. Now in this 10 is called root node. 10 is called root node. In order traversal, in the sense we are traversing the tree in a fashion left to root to right. Left to root to right. We are moving in this direction. Okay. Anyway, understand carefully. First, this is a generally recursive approach. First, I am starting at root only. Directly, it is not possible to move any place. I am starting at root node. What is the left child? For example, 10, some 9, 11. Here in this, 10 is called root. This is the left child. This is the right child. For 10, what is the left child? For 10, what is the left child? Observe, this entire thing is the left child for 10. This entire thing is right child for node 10. Here, first I started to root, but it is not visited. It is not visited. Why? In order travels means you visited in the sense print the data, print the values inside the node. So 10. Now for from 10 I am moving to 9. So here if 9 is the root, this is also a tree. Yes or no? 9 is the root for this 9. This one is the left child, this is the right child. So coming to 8, 8 is the root, this is the left child. For 8 there is no right child. 15, 15 is the root, 16 is the left child. For 16 there is no left to, there is no right to, completed. That is stop. Now print this value. Now the answer consists of 16. So consider this tree only. Move step by step under this tree. This is also a tree. Under this tree, what you are doing? First, we are printing the left value for 16. Actually, there is no left value. And then this value, root value. So, root value in the sense data. So, 16 is printed. And then right. Actually, there is no right. This is completed. Actually, this is the left for 15. So for 15, left is completed. Next, I am moving to 15. For 15, there is no right child. Now, this one is left to H. For node 8, left is completed. I am moving to H. For this, root is 9. For this, right child is also there, 11. Now 10. I think you got it. So simply move to the left to left to left to left to. So once the left, there is no left, print the data, move to the root node and then right to. Move to the root node and then right to. Move to the left to root to right. Here this is left to print 8 and then print 9 and then print 11. For note 10 this is left to 9 is printed and then 10 is printed. This is completed na. 8 to 9 to 11 10 is printed. Now coming to right again in this one, this entire thing is the right one. See, for 15 there is no left, so left is empty, left is empty, and then root 15, sorry, 13 is available. For 15 13 is available, so this is the child. For 13 empty, next to 13 and then 19 and then their parent 15. For this right child 20 14. This is called in order traversal. So anyway, actually this is not the class of data structures. Just to for your remembering purpose only I explain. Go to data structures also. Anyway, I will explain one more time. In order traversal, in the sense we are beginning at root node. Anyway, in any tree we are beginning at root node, move to the left to left to left to left to left to and so on. Finally the last node, for that node there is no left and right, print that one. Then move to their root, print that one, right child, root, right child, left node, root to right child, left node, root to right node. Like this only we are printing. So pre-order, whenever the pre-order, if pre-order programs comes I will explain. Anyway, pre-order is the logic is, first we are printing the root node and then left to and then right. That is what is the answer. First you are printing 10, 10 is printed simply. For this 9 is printed, 8 to 15 16 11 15 13 19 14 20. Observe how much fast. It's a very very simple. First 10 is the root node, this is the left child. For this 9 is the root node, this is the left child. 8 is the root node, this is the left child. 15 is the root node, this is the 16. So for this there is no right, for this no right, for this no right, for this root right is there, 11 is printed. So 10 already completed, this is the right. So in this subtree 15 is the root, 15 is printed, 13 is the left one, 13 is printed. So 90, here for 13 there is no left. 13, if left is there you need to put that value, there is no. 19 is printed. For this 14 the root and then left chain. Post order means left to right to root. Anyway, whenever we are moving to that one, we will discuss such problems also. That is not a problem if it is there. Now coming to the problem, how to write this program. Here if you observe this program, what happened, we are recursively calling like factorial. First you are calling the method, this is considered as the root, next to this is as the root, this one is the root, this one is the root, this one is the root. Whenever for that there is next to no element, stop. So recursively we are calling that one. Recursive 1 2 3. What is the answer? What is the first for 1? There is no left. 1 is printed and 3 is printed and then 2 is printed. See, 1 3 2. Observe here, null is there. That is no left. Write the program by using recursion. First I will explain recursion. If possible we will do without recursion also. We will do without recursion also. Anyway, already they given the terms val, left to right to. The variable names, whatever the names they are given, you need to use that one. If root, so root in the question only they given. See this one, root is none. If root is none, that means an empty tree. Why I am writing this condition? In the question given, see this one, root is empty. That is the reason. One second, please. none. If root is none, then what I return just to empty, just to empty. Else, this is important. What I return recursively, I am moving to the left part and then print the data in the root and then move to the right part. So return, understand carefully, recursion, you know that one, self dot, what is the function name, in order, whatever the name they are given, in order traversal of. So we are moving root dot left, yes or no, we are moving root dot left, self dot root dot left plus. Here we are printing the value root to dot val. Why I used square bracket, in the sense, since the answer they are placed in the square bracket, that is the reason I placed the square bracket, plus self dot in order, in order traversal of root to dot right. Observe, I already explained the same one. What happened? First, this recursion starting at the root node, root dot left, left side, left to side, left to side, left to side, so and so on. I am reaching to 16. For 16, for 16 there is no element. Okay, and then I am printing that value, printing that value. After that I am moving to the right. Once the left is completed, move to value and then move to the right direction, move to the right direction. So simple thing, left to root to, that means left to data, right to. If you remember in that fashion, in order traversal is a very easy. Now we will, generally in order traversals is there, pre-order is also available generally. Anyway, we will check at any point it is available. I think there is no pre-order traversal. Yes, well, see this one, pre-order traversal. Generally, if the question is given, means the question is related to all traversals. So no need to read this one also. What is the answer? 1, 2, 3 is the answer. 1 is the root node. For left, there is no one. In the right part, 2 is the root node. 3, 1, 2, 3 is the answer. See, 1, 2, 3 is the answer. I am writing the same logic. Understand? If root is none, if root is none, return empty. Else, return, first you are printing the root value, root to dot val plus self dot pre-order traversal of. So we are, once the root is visited, I already given, once the root is visited, root to left to right. So here root dot left plus self dot pre-order traversal of root to dot right. Pre-order traversal of root to dot right. Now run. So first to root to and then left to and then right to. Now submit. Yes, executed. Now Immediately move to the post order also. The traversal is completed. So post order. Now what is the answer? This one, left to, right to, and then root. So for one, there is no left one, that is not printed. Root is not printed. We are moving to this right part. In this, 3 is printed. Here there is no element. So now 2 is printed. Now 1 is printed. 3, 2, 1. So everyone, by taking some examples, practice. So here, first to left to, post order traversal of left to, post order traversals of right to, plus here, plus. So first to left to traversal, and then right traversal, and then print the value. Oh, runtime error. Okay, that is not a problem. Else, okay, copy 2 times. Execute. Oh, okay, okay. I mistake. I deleted post order traversal to, and then right to, and then root value. Now run this program. Okay, fine. Okay. So these are different tree traversals. So it is your task, before solving this example, you need to traverse. If possible, I will explain in this recursion. I will explain how to traverse step by step also. That is not a problem. If time permits, we will do level by level also. That is without using this recursion also, we will try to solve. No problem. That is also possible. Now, any doubts? If you have any doubts, please ping me. Plus means concatenation, yes. For that recursion, plus means the result is added. For the result is added. Okay. So thank you very much. I'm closing this session. If you have any doubts, please post your doubts in the group. Okay, thank you. Good night.